Okay, hello everybody, good evening. Can anyone confirm me if I am audible and visible properly? Okay,
Yeah, yeah.
thank you. Yeah, so good evening everybody. Today I am here to spell code of conduct do's and don'ts for you for this event. So, number one, be nice, respectful, and constructive while interacting on the Beway virtual or YouTube live chat, social media. Number two, do not post anything if any adult content, rude, or offensive statements. Number three, do not advertise or promote anything. Number four, do not spam, post same thing again and again. Number five, harassment of any kind is not tolerated in this event. And if you fail to follow this code of conduct, you will be blocked from interacting on the chat. Last but not the least, report to GDSC at the lpu.co.in if you find anything inappropriate. So yeah, now I request my team to take charge for today's session. So over to you, team.
Hello. Am I audible? Can anyone confirm? Okay, so good evening, everyone. We are from Google Developer Student Clubs LPU, and today we are going to organize a session on Introduction to Machine Learning with Google Crowdsource. Before starting, I just want to request you to please download Google Crowdsource application from Google Play Store if you haven't downloaded it yet. So we'll be waiting 1 or 2 minutes so that everybody could download that application.
I hope all of you have downloaded the app, right? So that we can proceed. Can I get something on chat? Yes, no, maybe something. Okay. Now I'm handing over to Rupinder. You can share your screen and proceed with the event, right? Right.
So, is my screen visible?
Yes, perfect.
Okay, so let me first introduce myself. I am Rupinder Palse, current AI/ML team lead in GDSC, and I would like to thank Mr. Surajmani, our GDSC lead, someone who is very interested in cloud computing domain, for giving me this wonderful opportunity to host this event. So we'll be starting with a basic introduction. I'm just explaining what will be there in this session. So we'll be starting with basic introduction to ML with crowdsource, followed by some interactive games, how those games are working, followed by spending some time discussing which approach you should use while you solve a real world problem. And if you decided to solve a problem using machine learning, how can you convert your idea to implementation? That is, how can you convert your idea into a code? Okay, then we will talk about certain types of tasks in machine learning, and we will end this part one with some Q&A. So this whole session is divided into two parts, and then the part two includes discussion about neural networks and Google's teachable machine and TensorFlow playground. So let's start with an introduction video from our Google about what exactly is the term machine learning means.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer program to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Well. That was an interesting video. So I hope you got a gist of what machine learning means. And now I hope everybody has downloaded the Crowdsource app. So please open the app and go to the smart camera tile. And just a little note, if you are already a user, it's okay. But if you are not, you will be asked permissions to download the machine learning model that the smart camera is going to use. So here are the steps, and we'll be doing it live. Let me just show you. So I hope you all can see my phone. Please write in the chat box. Yes, so here is the smart camera app. Okay, so this whole platform is known as the Crowdsource. So it is a platform built by Google to just make people contribute to their machine learning algorithms and machine learning data building. So let's start by just going to smart camera. And here what we do is we point it to an object and just tap on object. So here you can see it shows that this is glasses. So this is what this model that you have downloaded just a few steps ago, that is 5 or 6 MB, that this model is capable of recognizing what object in a picture looks like. So if you click on yes and submit photo, what it does is it goes it goes to the Google's open source storage, and then Google uses those pictures to improve its machine learning model. In this way, you are contributing in improving Google's machine learning task. So let's make it figure out some more tasks like this. I have phone here. Now you can see it is saying that it is a mobile phone, and indeed it is the mobile phone. So I will tap yes and submit that photo. We can see our submitted photos at my uploads, and these are the photos that I have uploaded till now. Let's see if it can recognize whether a pen or not. So here, what we see is not all the models are not the models is always 100% accurate. Like it is actually a pen, but it is showing that it is a screwdriver. Let's try let's try changing it a little bit. Now, how can we improve this? We can contribute, like I said, we can contribute. And how can we contribute? Like it is showing a screwdriver. If I tick no, set yes, and set wrong description, I am writing the right description here. Like I would say, it is a pen, and then I submit. So now it goes to the Google storage, and then Google utilizes, okay, this was a pen, but it was misclassified as a screwdriver. So there they can improve that thing. Like just the last one. Okay, so it is showing it is a computer mouse, and indeed it is a computer mouse. So this is pretty much it. Uh, that's how we can contribute it. That's how we can contribute to open Google's crowdsource application. Let me stop sharing my screen. Okay. Okay, let's get back to. So I'll be waiting 1 or 2 minutes so that everyone could try it. Okay. So what you have to do is just uh, open the smart camera app. Okay. Show it some object and see whether it identifies correctly or not. And please post your result in the chat. Please don't forget to post your result in the chat whether it successfully classified what it sees or not. Okay, so I'm seeing that 2 people are done, but uh, They haven't told me that whether it was successful or not. Please post your result in the chat box so that we can see how this model is working, how much effective is this. Okay, so I see I, many people are writing successful. Okay, Mansi Singh is writing not able to recognize pencil. Okay, that's the case. I think it's recognized it incorrectly, that it is a screwdriver or something. That happens all the time. Not all the machine learning models are 100% accurate, and this is what you are contributing to. You are contributing to improve that so that it doesn't misclassify it again. Okay, so I got a few responses. So let's just move ahead because okay, there are a number of games and tasks that we are going to do in this session. So let's move with the next task. So heading to okay, just before the task, there are a few questions that you should be able to answer, or I should just explain it. So I have already answered question three, that how could we improve this program. So you already know that you are contributing this to crowdsource and telling us if it performs good or not. So that way you help us to improve this program. Okay, so coming to question number one, how does the image identification work? And question number two, how it is recognizing the object. So we'll be answering this question later in this session, and I will show you the exact slide, or I should say exact task, how it is doing. So just stick with me, and I'm gonna show this how this is happening. Okay, so let's head to another interesting game, and I'm sure that each one of you have played these games at least one in your life. Oh, so it's called Quick Draw. So you can go to this website. Let me just paste it in the chat. Everyone, please go to this link and see what it is capable of doing. So as it said, so this is made with some friends from Google, and let's just stop talking for a bit and just play it. It says draw broccoli under 20 seconds. So let's draw it.
I see line. Or stitches. Oh, I know. It's broccoli.
Okay, so it was able to identify it correctly. So I have to draw train under 20 seconds.
I see skyscraper. Or carrot. Or garden hose. I see toothpaste. Or toothbrush. Or police car. Or fire truck.
My drawing is
I
very
see
bad,
ambulance. Sorry, I couldn't guess it.
so now it's asking me to draw a house under 20 seconds. And let's see whether it recognizes or not.
I see mountain. Or pyramid. Oh, I know. It's house.
Now
I see nail.
let me draw a flag.
Oh, I know. It's flag.
Now it's asking me to draw a crab. Can figure
I
out
see circle.
how a crab looks
Or
like.
moon. Or sea turtle. Or table. I see frog. Oh, I know. It's crab. I see circle. Or moon. Or blueberry. Or snowman. Oh, I know. It's teddy bear.
Okay, so it says our neural network figured out 5 out of your doodles, but we see something else in doodle one, in one, that is train. It doesn't recognize is that this is a train. So we'll be talking about how this is working exactly. Just a moment. later this. So are you doing it? Are you following me? Are you playing this game? Isn't it interesting that whatever we draw, how so it is onto us that how can we draw it and it recognizes it correctly. Okay, I see few responses. Uh, okay, so let me just tell you, ask you a few questions again. So how does this games work? How it is recognizing your drawing, and how could we improve this program? Again, to answer the question number three, I think you already know the answer. You can go to this crowdsource application and contribute it there. How does the games work, and how does it recognize your drawing? So for question number two, you have to wait just a little longer because I'll be talking about how it is recognizing. Okay, so how does this games work? Let me throw some light on this. Okay, so here is a clue to how the games work. There is a large amount of data to teach this game and how to recognize images. So if you go to this website called Quick Draw Data, you can see a lot of example for an object. Let's go to this website. And here we can see there are a number of objects that are being drawn by the real people in the real world. So let's pick up randomly from here. I think I should pick randomly like what should I pick? Okay, let's say I pick ceiling fan. So you can see we are looking at this number of ceiling fans, and these all are different from each other, and these are the drawings made by real people on the internet. So what the Google does is they give this data to a machine learning model and let it figure out, okay, what exactly is the pattern between these data. Okay, so it has a little tail here. Okay, some fans have 4 wings, some have 3 wings, some have even wings. So machine learning models learned and recognize this pattern. So whenever we draw this type of pattern, it says, oh, I know this, it's a fan. And that's how machine learning works. Okay, so let me just talk about few um, approaches. So first is you may already be familiar with the traditional programming where you set a goal, write logical rules, and refine through testing until it works the way you want it to. So imagine if you try to describe a carrot, which is just one example out of those thousands of examples, the way you just described using traditional programming on rules such as those on the right side, like if you can see here, it says if height of the object is greater than 10, then do this. As okay, I have to do this. If the color is blue, I have to do this. If number of legs is greater than 2, I have to do this. Okay, so this approach would be very complicated, especially if you want to account for all the possible ways which one could draw an object. Like there are literally more than 1,000 ways to describe a computer. How does a carrot look like? Okay, so and figuring out those 1,000 ways just by traditional programming is so difficult. So what we does is use machine learning, provided data, lots and lots of data, so to a computer, and ask it to figure out what does a carrot look like all by itself. We have to do nothing. We just have to prepare the model architecture and give it the data. So, okay, I am giving you data. This is the architecture that you are going to follow. And you have to learn what is a carrot, how to draw. It have to learn its own. Okay, and that's pretty much it how the machine learning works. We frame the goal of the product, we train a model using examples and refine it until the goal meets. Okay, so I said, okay, this is the carrot. It says, okay, I still can't recognize it. So how can we refine it? We can change certain parameters. We can give it more number of examples that says this is the carrot. Now, there are certain questions regarding which approaches to use when you are programming, uh, when you are solving any kind of real world problem. So first problem is alphabetizing a list of song titles. So according to me, it's a rule-based problem and it can be solved using rule-based traditional programming. Because see, what you have to do is you have to sort the song titles according to the alphabet characters. Like A comes first, B comes second. There is no machine learning it. This is the simple rule. Like A comes first, so song titles with A comes first, and then B comes, that means all the titles starting from character B will comes after all the characters with song titles A come. Okay. Ranking web search results. I think for this problem we can use both machine learning and rule based approach because it is totally dependent upon the goal. That whether I want to whether I want search results according to my query, or do I want to account what other people found useful when they search the similar kind of question, like you saw in Google. Like you search a keyword and it show you the result, and it also show you the top results that are being marked correct by the other users. Okay. Next is the predicting house prices based on location. So for this, I think we should use machine learning and only machine learning because again, the figuring out the exact price of the house using traditional rule-based programming will be very difficult and inefficient. Because based on the features like a number of rooms, kitchen, lawn, etc., we can tell what the exact price is. And also we need to take many things into account, like what price does neighbor house cost, what facilities are provided near the house, and many more. And taking all these into account all by ourselves is a pretty messy task, so we let the machine learning model figure this out, that what affects the price of a house the most and what the least. So I think the machine learning should be used here. Okay, so next is uh, processing online payments. So I think it can be solved using simple rule-based programming because see, we already have a set of defined rules what to do by processing online payment. Okay, so you have to enter a UPI ID, you have to search whether it exists or not, you have to check whether the payment is received by the other person or not. So these are simple rule-based. There is no machine learning involved in it. So we can solve these by rule-based. Again, this classifying an object in a photo. So I think it's a machine learning based problem because we have to consider a lot of parameters while classifying an object. And believe me, it's a pretty hectic task to classify an object in photo. There is a huge amount of computation power is required just to classify simple things. So now we have to consider a lot of parameters by classifying an object in a photo, like what is the shape of the object, what is the color of the object, what are its dimensions, and many more things. Again, all we have to do this very fast and very efficiently. So we'll just use machine learning approach to just figure it out. Now here's the so Archit Nagpal said, "Sir, how do we get to know what model is best for a particular data set?" Okay, so Archit, I would just like to describe you that when you Google certain questions like what the model should be used for what machine learning problem. So there you will find a quick map about on the sklearn website that shows, okay, if you have this much number of samples, you should use this machine learning model. And if it's not working and your data is very poor, then it tells you to, okay, improve your data, either improve your data or go to next machine learning model. So there is a quick cheat sheet on the sklearn website. So I can show it to you after this session. Okay, so here's a quick recap about what we just saw. There are two approaches basically. One is rule-based and one is machine learning. So a rule-based approach, where a certain set of rules are defined, and the improvements came from the algorithms and network. Like in case of rule-based, we have to analyze it thoroughly, that how and where can we improve our algorithm. We have to hard code it. And what we do in machine learning, we just give it the data, we just describe the structure, we just describe the how the structure architecture of a machine learning model is, and give the data and let the machine learning model to learn the pattern from data. And how does it improvements come from? It comes from the this additional data, and again from the cloud source application that you people are contributing it. So each approach has its own benefit. Like rule based can be, we just saw rule based can be used for certain things, and machine learning can be used for certain things. So that's pretty much it. Oh, okay. So let's now talk about the idea to implementation. And here I would like to invite our team member, Ms. Tanveet Kaur Gill, to take us further. Over to you, Tanveet.
Hi everyone, my name is Neet Kaur and I'm a second year BTech CSE student. From this point, I will be taking over the session and letting you know how we can implement ideas in ML using various approaches, types of machine learning, and furthermore. Let me share my screen. I hope my screen is visible. Can you confirm in the chat box? Okay, thank you for the confirmation. So moving forward, while machine learning offers powerful new opportunities, implementing a machine learning system can be more complex than traditional software. This is primarily because a machine learning system is only as good as the data it is trained on. In this section, I'll provide an overview of the process as well as the important considerations that we should take while using machine learning. So first we will view a video regarding the same so that you can get an overview idea about what machine learning actually is. So let's view this video. Hope
Suppose you have a
is
great
audible.
business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn. Along the way, there are quizzes to check knowledge and correct misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Okay, that was about the video and a brief about what machine learning process is all about and what steps are included in this. What we are machine learning process. Machine learning begins with the needs of our user and business. With this in mind, you define an objective so you know how to proceed. For example, there may be considered examples like predicting which friends a user is likely to share a photo with, or suggesting the user what he or she should eat in a new city based on the restaurants that they have visited in the past. These goals should articulate success matrices as well. Machine learning models learn from examples, so it is essential to find a large existing source of data that is relevant to our problem. Apart from this, the arrow pointing to back from prediction to data shows the iterative nature of ML. You will need to refine your model and perhaps your data collection and processing based on the feedback until it is achieving the results that you are looking for. Then moving ahead, we have another video in which we already know that humans are prone to trust results from a computer. We assume our technology will work as designed until it breaks. However, even a well-designed machine learning pipeline can experience issues or outrages when it picks up on biases or flaws found in the data. Regarding this, I will show you a video which will give you a brief idea what I'm talking about so that you can get a better understanding. Hope the sound is clear this time. Wait a second.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why. Each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. Our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. Selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, on the search bar, so people can flag hateful or inappropriate autocomplete suggestions. Issue, and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Well, that was a very informative video. Now we'll view some ML privacy related issues in a video again, which will clearly give you a clear-cut idea what ML privacy actually means regarding the data and how to use it in the machine learning. So moving forward, we again have some video.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. Challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a fever might be diagnosed with the flu. Plenty of other factors influence diagnosis too. Have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used by healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
Now, moving forward, these type of videos may arise some questions like what can ML actually do? For this, we will moving forward. It's easy to look at examples of machine learning that we have discussed recently or see it as magically something different or very charming. It does open a lot of new possibilities with technology. We already considered for certain situations whether ML was necessary. In this we will discuss what type of problems ML is best suited for. So going forward, first there are these three terms which may be confusing to some of you, like what is artificial intelligence, machine learning, deep learning. In news articles and discussions, it is common to hear artificial intelligence, machine learning, and deep learning used interchangeably, but there are distinctions between all of them. Artificial intelligence is defined as a technology which appears to be something smart. This can be anything from program software to deep learning models which mimic human intelligence. Whereas for machine learning, we can say that machine learning is a specific kind of artificial intelligence, but rather than a rule-based approach, the system learns how to do something from rather than being explicitly told what to do. So it is kind of machine learns from it. Then there is deep learning. Deep learning is a specific type of machine learning using a technique known as neural network, which connects multiple models together to solve even more complex types of problems. Okay. In a nutshell, that brings us to a very simplified overview of the history of machine learning. You can find more detailed timelines on Wikipedia, but here is the main takeaway. The key algorithms were formulated even as much as centuries ago. They come from the disciplines that we learn every day, like statistics, linear algebra, biology, physics. For the last few decades, large amounts of data were collected to train models, but they were low in quality and expensive to train. So this progress and prospects lead to an AI winter where ML was considered a waste of time. In the last few decades, the availability of relatively cheap computing power have enabled the complex calculations across large necessity to train highly accurate models. So for the learners, I maybe draw from which they can learn more about these topics. Uh, Here is one where which you can know about the timeline of machine learning. Also, this one where you can get a better view of what history of machine learning actually means. So let's move forward. Now we will discuss some application or types of machine learning. The first one that comes in our mind is classification. Classification is a common application of machine learning. The system determines which class an example belongs to. The output can be and the percentage of confidence. It depends. For example, if the classifier was trained to identify whether or not an image was of a lion, it might output yes or no. However, if it was more generically an animal classifier, quite different from what we have been talking earlier, the output can be lion or a tiger. Classification systems depend on the threshold set by developers. So the system can distinguish between cases that might be less clear. If you build an email spam classifier, it would be necessary to fine-tune thresholds so your system didn't incorrectly label an email as spam when it was actually genuine. Then moving forward, here are some GUI games on the Crowdsource app that we have already told you about, which you can check out later, which are based on classification so that you can get a better view of what actually classification means by playing these. There is sentiment evaluation, image label verification. Then there is smart camera, which may be fun to interact with. And moving forward, we have next one is regression. So regression systems majorly depends on output a number. For example, how long it take to drive from a point A given to the point B, or the likelihood that someone will click on an ad. Regression systems can be as simple as drawing a line, as you can on the screen, or more complex models depending on the multiple variables that there are. Then after regression, we have clustering. Well, another application of machine learning is determining how closely related items are to one another. In this slide, the data of hand-drawn images is moved clusters of the same numbers. Like you can see in the first box, there are ones, and in the second, there are twos. Even within clusters of the same number, the images are further by those which are similar in shape. Like some may be classified as sevens, so because twos and sevens may look similar, so it creates a different cluster for them. Then going ahead, uh, another game called semantic similarity, which you can go through in the Crowdsource app, so that you can get a understanding what clustering actually means by implementing it. Then there is sequence. In order to assist users, it can be helpful to what they might do next. This could be a prediction of the next keyboard key a user will select, as you see in the screenshot. This could be used to propose a spelling correction or suggest you to the replies to a text message that you are going to send. Other examples include the next video that a user might want, the next job on notification that he or she wants to. Hope I'm clear up to this. Then there are types of GUI games like and recognition or translation tasks. You can go over. We have one more application which is transfer or involves training model on data and then applying that to something completely different. Could be as seen in example making photographs, another piece of art, or translating from male voice to a female, or even language. Now that you know some great machine learning, let's some specific examples which are related to machine learning.
I think there is some network issue, so please wait for a while and let's get the meet back on the platform. Just wait for a while.
I'm sorry guys, I think I faced some network issue. Let me reshare my screen and let me know in the chat box if my voice is still lagging. A second. Hope my screen is visible and my voice is clear. Okay, thank you for the confirmation. Okay. Okay. So there are some types of machine learning examples given ahead, and I will be telling you which category they belong. So let's move forward. Okay, the first one is recommending next word in the Android SMS app based on the words typed so far. So the first application is an example of obvious sequence prediction. There is given a specific sequence of input words. Predicting the next word is the canonical problem for sequence modeling. But the most important point that we should keep in mind by doing that is sequence prediction is that the ordering of the inputs or outputs or both is meaningful to the problem to be solved. So that's the main takeaway that we should keep in mind while knowing about sequence prediction. And then moving forward to the next slide, there is the application of labeling email as spam or not spam. So this category belongs to the classification. The major reason behind this is that when the goal is to output discrete prediction labels like yes or no or spam or not spam, this is a good fit for a classification system. Okay. Then the next one is identifying trends amongst a group of people who have brought a new music release. This example majorly belongs to the clustering domain. The goal for this problem is less about making a specific prediction like the sequence prediction example earlier, but looking for similarities and finding cluster trends groupings based on something that is common. Here we can say that the people who have bought some new music release or have a common taste is being talked about here. And the next is a bot that reads the news in the voices of famous actors. I think we have covered this recently, like the style transfer in which the male voice was converted to the female voice. Similarly, the goal for this is that we convert different type of voices into another, and or maybe we can translate them also. Most common real examples of style transfer these days are fakes, like the fake voices that created by some artists in a movie or some radio jockey show. Okay. Then there is this next one, determining workout activity based on phone movement. So this comes under classification. The goal is to output discrete labels such as walking, running, jumping, which makes this task a good fit for the classification. Then the next one is identifying famous landmarks in a photo. This is again a application of classification. When the output is a discrete label such as Eiffel Tower, Taj Mahal, Great Wall of China, Statue of Liberty, etc., it is a classification problem. Then the next one is suggesting spelling corrections. This comes under clustering. Clustering because words which are misspelled may end up closer to the correct spelling than the completely different word. Then again moving forward, we have predicting the quality score for an advertisement. This comes under regression. The output of the machine learning system is a continuous numerical score such as 3 out of 10 or 97.2%. This score would probably be based on the numerous features of this type of machine learning. As we have already covered in the previous slides, that regression mainly focuses on the number. So the quantity that comes out in number is majorly an application of the regression. Then moving forward, we have estimating arrival time based on the time of day and traffic. This also comes under in regression because the output of this system is a numerical value which such as 1 hour or 5 minutes, or it can extend up to many hours as we know. Then going forward, we have translating between two languages. For example, this comes under sequence prediction because although both the input types may be the same, text, audio, the languages are different. Then going ahead, okay, so we have almost covered these type of questions in the previous slides, like what is ml versus rule based idea to implementation, and what is AI versus ml versus deep learning, and various types of ml. So hope that all these topics are clear to all the viewers, and also if you have any questions you can drop. Now this is the end of the first half of the session. Now I will be giving the stage to my co-host Rupinder to carry on with the second half. Over to you, Rupinder.
So I think that was a thank you for your time, Tavneet. Okay, so let's start with the part two of this session, that is neural networks. I hope my screen is visible. So, what are neural networks? If you have read anything about machine learning, and you may have come across the term neural network, and they are a popular choice for machine learning models because of their ability to handle complex data and make accurate predictions where simple models might fall short. So there is another video, and let's see what our friends at Google has to say about neural networks.
Rupinder, I think audio is not there. Do share the system audio as well by representing.
Audio is not audible.
Yep, it was not audible. Just close the sharing and then reshare the screen with audio check.
Okay. Is it
Learn
audible
more
now?
about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and like simulate how galaxies move and how.
Hi, I'm Nat. And I'm Lo. And this is our 20% project, where we go find out about different Google stuff we're curious about. Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning. Since then, we've been kind of fascinated by it. So today, we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and like simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it. But for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters. When you go to the ATM and you give a check and it can read the handwriting. Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos, here are all my dog photos, here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we would just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. Ooh. So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn.
But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog. And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the atomic ideal of a
Rupinder, you are maybe on mute, I guess.
Okay, sorry. Can you hear me?
Can go ahead.
Okay, so I was saying, if you have to explain in short what a neural network is, how can you describe someone? Please write in the chat box that how can you describe someone or tell someone what exactly is a neural network is. Please make it short. Okay, one or two sentences are enough. Please write your answers in the chat box. How can you describe someone what a neural network is? I hope someone is writing the answer. So I'm waiting. I'm still waiting. Okay, so Garvit Joshi has written combinations of several input to provide a common output. Okay, that's true. Let's see if someone has to say something. Okay, so Ravi said a computer system modeled on the human brain and nervous system. Correct. Again. So if someone asks me how could you describe what a neural network is? Well, I should say it's a mathematical function that maps a given input to a desired output. Okay. So in the introductory module, you have learned about different types of machine learning models like classification, regression, etc. So a simple model works fine with the data, but what happen is as soon as you want to interpret complex data like this image, this image is here, audios, or even the simple data, but again with the lots and lots of features. Like let's say we have to predict the house price, and that prediction of house price depends on 200 plus features, then you should need something capable of dealing with that type of complexity of data, because normal traditional machine learning problems can solve that, but it is very inefficient and very slow process. So this is where neural networks comes into picture. In reality, a neural network is a big complex mathematical function, and it doesn't look like this picture that has been shown here, because it is just a representation of what might going be inside a neural network. So let's describe this slide a little more. What you see here are the two classes that we have to look for. One is cat and the second one is dog. These are the layers, and the dot represent the neurons, where each dot represent a single neuron. And these connections, these are the internal connection that input layer is making to its next layer, and its next layer is making to its next layer, like we had seen in the video. So remember, you have seen how we got exactly one of the two classes. Like here in the output, it is saying that it is a cat. So how does it does that? That all happens with something known as the activation function. Again, it is a mathematical formula that helps us to decide what class does this data belongs to. Like neural networks, what happens is neural network predicts the probability of the class that a data point may belong to, and then we have to choose the maximum probability of being in that class. So let me show you some activation functions. So there are some common activation functions like this sigmoid activation function. And what it does is whatever you pass at it, whatever any value, it always convert it to the range from 0 to 1, and you get this line here, this curve line. And here we have the rectified linear unit called as ReLU for short, and that takes a maximum of 0 and the data provided itself. Of course, there are a lots and lots of activation functions out there, and all of them has their own use cases. So you can check it out on Wikipedia. Uh, these activation functions are somewhat similar to the if, else, and then statement. Like check if it matches the threshold, then do this. If not, then do nothing, and all. So let's see deep what the activation function really is. Like we have input here, we have activation function. If it activation function passes, then it will activate the neuron. That is, neuron will perform certain task. And if it doesn't allow it, it doesn't do anything. Let's say we have activation function. Okay, this is just a hypothetical activation function, just to describe what exactly is going on. So let's say we have input value of 5 and activation function said, okay, if the whatever I receive, if the value is less than 10, I will allow the neuron to do something. That in this case we indeed have a value 5 that is less than 10, and it allowed the neuron to fire. That is, it allowed the neuron to do something. Like in this second image, we have 7. And this activation function looks for a curve. And it asks, okay, does this input have a curve? If not, okay, do nothing. Just do nothing. In this image, we have 6. And again, this neural network, the activation function asks, okay, is this image have a curve, or this pixelated image that is 6 does have a curve? And it said, okay, I can found a curve here. Like this is a pixelated image, but when you zoom it out, okay, you can see this is forming a straight curve. Then it says, okay, this has a curve, and I will activate the neuron. Okay, and then it will do something that we have programmed it to. And this is a high level overview of what a neural network, what a deep neural network is. Like we have given a picture, different this neural net neurons, that is, are looking at the different sides of the images, and they all combining their results to predict what this image might contain. So according to this image contain the laboratory retrieval. So okay, so, I think it's finally time to see how things actually works. Like I've said it earlier, we will see it later. We'll see it later. So this is the time. Let's take it further and head on to CNN Explainer website. So here we are at CNN Explainer website. Now to explain this, I will create a scenario. So just hear me out. We have 10 or more so different types of classes here. Let's say we want a neural network to recognize a cup, or in this case an espresso. So consider this whole network as a class of small children that represent this. Every neuron represent a small child, that is. And we have a teacher that represents an activation function I just saw. Now what each child will do is it will look upon some detail and say, and let's say this child, let's zoom in some. Okay, as you can see, this child here, okay, this is the process of learning. It is figuring out some values of its own. Like here is a matrix, it will multiplying it with weights. Weights, you can consider weights somewhat as how much importance does you have to give to a feature or a value. Like it is saying, okay, it is minus 42% important. Okay, this is okay. So I'm just explaining not exactly like this. Like it's saying, okay, I have a weight of minus 0.42 for this pixel, and I have 0.16 weight of this pixel, and I have minus 0.2 weight of this pixel. So that's how it keeps learning the new things. Now let's say, and also, sorry, I forgot to mention, these three represent the three color channels, that is red, green, and blue. And we all know that every pixel is made up of three color channels, red, blue, and green. So let's say this child here, it said, it looks upon the object and it said, okay, this object is cylindrical. And the second child here is said, okay, this object have a round handle. And this, let's say this child here, it said it has a round top. This way each and every child said something. And finally we have the teacher here, that is our activation function. You can see how it is taking all the sayings of the child into consideration and predicting. So now, in this way, after hearing every child about the object, it's the teacher's turn to make the final call and say whether this is a cup, or in this case espresso, or not. And that's how a neural networks and activation function work. Like this activation function we are using here is softmax, and it is taking all the predictions into consideration and saying, okay, I am 88.16% sure that this is indeed a cup, that is espresso. And we can see here it is about 10% or so saying that this is orange, but as I already said, we have to take the maximum into account. So it is saying that 88% is the maximum. Okay, so I think it is a cup. So now again, talking about how should we improve it, then we can improve it by providing more and more good quality of data. And you can also contribute by, again, I'm saying, you can go to Google's crowdsource platform and contribute it there. Now, there are certain tasks again, like the smart camera we just saw and image level verification. You can go to crowdsource application. You can, okay, so Garbage Joshi, I see, okay, Garbage Joshi has given the uh, website detail. Okay, yes, this is the exact website. You can go it and see it yourself. This is an article type website. You can read upon it. Okay, so what is the convolutional layer? What it is doing? What are the hyperparameters that is taking out into? What is the value activation function that we have just saw? What is the softmax function that it is using for making the final call better? What is it? What it is? We have the pooling layer, flatten, and we have the interactive video tutorial. So you can do this task by your own by going to Google Crowdsource application. Now there are some other tasks that we are going to do. So again, I would like to invite Prajwal Kumbar for the further task.
Hello, everyone. Yeah, thank you, Rupenda, for giving me this task to do. And today we'll be doing a hand-on experience on neural playgrounds. Well, I think the screen is visible and I'm clearly audible. Yeah, this is the neural playground, and where we can. This is a mini AI neural playground where we can do the things how it really works in the world. And this is the learning rate where means with the what rate we are training the model and so on. We can change this with the seconds and the timings and activation as Rupender said, the symbolic learning and uh, RELU and something and all this. And we have classifications. We know that in the ML we have classification and regressions to type. We can change this according to those. And these are the datas how means the models after our training the models will be classified with, this is the simplest bit tougher one and this is the simplest and where we'll find the straight line over this when we train the model we'll get the equation as y is equal to mx plus c. And this will be the most toughest one where it has to take the all the orange path according to the orange lines and the blue color with the blue path. So next, let's begin with this training part. These are, let's suppose this x1 and x2 are the inputs where we have two images called cat or a dog. And these are the hidden layers where we have the layers to train the model. We can keep on increasing them and decreasing. And each input is connected with a hidden layer you can see over here. And the hidden layer is connected to the next neural network to give the outputs. Epoch, the basically epoch means the number of trained model, the number of trained model will be shown over here. And so let's begin it. This is the number of loss percentage we are getting, means the accuracy is still 0.5 or 0.4. Yeah, no. You can change this, see the changes how it fastly it is taking. As we are training the complex model now, it is taking a bit more time. Yeah, from this point, it won't go further more because the layers are too small and we need to increase the layers. Yeah, now that it is going right. The loss rate is getting decreased slowly. Yeah, the model is bit taking time still more. Let's change the data set and see the new. You see the time taken is too less and the loss rate is also 0, and we can see the straight line for this. By this we can predict that the toughest data set will take the more time and we need to increase the layers according to it. So this was a showing the how the neural network works, and I'll hand over to Rupender for the further talks.
Okay, so that was very interesting watching it. Okay, so we are heading to the end of the session, and at the end, now let me show you something really, really interesting. So, have you heard about Google's teachable machine? How many of you have heard about the Google's teachable machine? Please write in the chat box yes or no whether you have heard about this teachable machine or not. Okay, so Mansi Singh said no. Naidu said no. Okay, so let me Google it out. Google's teachable machine. So what this platform is, it allows you to teach a machine learning model quickly by just providing it the data, and with a few configurations, you can achieve a great machine learning model that you can use it in your projects also. So let's get started and train us. Let's say I have to train an image project. So I click on the image. I am using standard image model. Okay, so it can be exported to TensorFlow Lite that is used by the Android most of the time. TensorFlow that is used by that we use in the desktop for most of the time, and TensorFlow.js that we are using in the web-based applications to just integrate our machine learning model in the web itself. Okay, so I have certain classes. Now, what I have to do is to train the model and to make a prediction, I just have to upload some images. Let's say I uploaded these images. Like I have images of cat here. And I said, okay, these are all the cat's images. Again, upload something. Let's say I have dog's images. Now, I'm just creating this data so that I can train upon it. So here I'm saying, okay, these are all the top images. Now heading to next. I'm saying, okay, these all images belongs to keyboard, and each and everything in this image is a keyboard. Let's add more classes. I think I've added more. Okay. Let's say I have mouse images, and these all belong to mouse. Okay. So what I'm doing is I'm creating a data set, and I'm saying, okay, these are the cat images, these are dogs images, these are keyboards, and these are mouse. Train a machine learning model, make a prediction, and tell me how accurately you can predict based on these images that what the new image I'm providing you. Are you able to predict it correctly or not? So let's train it. It said it's preparing the data, and we just have to wait for a few seconds. Okay, all the training done, and it's ready to predict some values. Let's say I choose randomly. Okay, so I have created this test folder, and let's say I provided it this image, and here it said, okay, I am 100% sure that this is a dog image. Let's test it further. Choose another image. Okay, so here it is saying, okay, I am 12% sure that it is a dog, but I can't see a dog here, so this is not 100% accurate. But it said, okay, I am 77% sure that this is a keyboard. That means it is performing pretty well. It is able to identify the data correctly. Let's say we have this fancy looking mouse here, and it said it's 11% sure that this thing is a cat, and again 11% sure that this is a dog, and it said 72% sure that it is a mouse. Okay, so let's try to confuse this a little bit. Let's see what this image does to this model. Okay, so here we are. This is indeed a mouse, but it said, because of this dog image painted on this mouse, it said, I am 52% sure that this is a dog image. So here this machine learning model fails. That is, we have provided the data correctly, but this image that we are predicting on is not the good quality of data. So that leads to the error. And you can see it's only 40% sure that it's a mouse, but 52% that, okay, I know this is a dog, this is not a mouse, but that's incorrect. Again, let's try it with this thing. So although we have a dog photo here printed on this keyboard, but it doesn't predict anything. It said, okay, I'm 100% sure it is a keyboard. That means it has learned to predict the keyboard very accurately. So what you can do is, if you want to use this model, this trained model, this that is trained on these number of images in your project, what you can do is you can export this model. You can download it in any form, whether it is compatible with TensorFlow.js, only TensorFlow that is desktop version, or TensorFlow Lite that is mostly used in the Android applications. So let's say I have to use it with TensorFlow that is the desktop version. So I'm not downloading it again. That is, you can download it from here. You can copy the code to run it in your machine. Okay, so I'm not downloading it again because I've already downloaded it. So I'm just showing you the code, that how it is working. So this is the code. Okay, so I have just copied that code, and what I have is I have gone to this test folder, and I have certain images. So here I am importing that model, that is I am downloaded. You will get this converted keras.zip file when you download this model. It contains following: the labels, that is 0 represent dog, 1 represent keyboard, and 2 represent mouse, and the model itself. Now let's get back to the code. This is the exact code that we have just copied. Let's run it. And it is taking, okay, so let me give it a image. Let's say dog. Okay, so it ran successfully. There are some warnings that we can ignore because these are all the depreciated warning. That we are using some features that will not be available in the future. So let's, for the time being, just ignore this warning. It says it took 2.9 seconds and it predicts what this dog.jpg is. Let's see what does it say. Okay, so this is the image, and what it said, this image is a dog. So that's how with the code, you can use your model that you have just downloaded from the internet, from that teachable machine thing, and you can use it in your any project. Okay, let's try giving it another image. Let's say I give it mouse image, run it again, let it make predictions. Run it again. Okay, so it is saying, okay, I'm seeing that this is a mouse. And that's how you can download, export your model. You can use it for different Android, desktop, or web-based applications. And it is pretty interesting. You don't have to hard code all the things. You don't have to know machine learning a lot and lots of code of TensorFlow or Keras. You just have to upload some samples, and you can go to advanced. You can set these parameters yourself to configure it according to your needs, and you can download it. It's just that simple. So now I'm pretty sure that by the end of this session, uh, you all can answer these questions like what is a neural network, when it is useful, what can do to a simple model that might not able to do, and what is the limitation of neural networks. So this was all by crowdsourced by Google. Uh, Apps that help you contribute to open source machine learning projects and help you to contribute more in the machine learning task. So you can go to this application and you can level it up. You can contribute more. Now, let me share this link. So this marks the end of our day one session. So everyone, I request everyone to just fill out this form and tell us what is the most important thing and what is the most fun part that you like about this session. And also, we have another session that is tomorrow for intermediate machine learning, in that we will talk about problem framing, how to frame a problem in a machine learning, and introduction to machine learning part two. Like we will discuss different types of machine learning, whether it's a supervised, unsupervised, reinforcement, and all that stuff. Okay, so that's pretty much it. Pretty much it. So, Suraj, should I end this session? This Hello, Suraj, can you hear me? Should I end the session now?
Yes, for sure. Make sure those who are here, you must fill in the form with beginner track only, and the session will be happening soon for intermediate track. So stay tuned till then, and then you can fill in that form as well in past. You can scan this QR code for now to fill in that form, or you can take in the reference from the link that
And
is.
also, you all be getting the certificates for attending this session.
Yep. And thank you everyone, and let's meet very soon for the intermediate track, and let's make this happen. Okay, bye bye. I'm closing the meet very soon. Bye.